Mr. Sutton here, bringing you the Algebra 2 Honors 3-5 homework solutions on solving nonlinear systems of equations with graphing, substitution, and elimination. To solve this system of equations by graphing, we're going to plot both of these on Desmos and see where they intersect. So here we are on Desmos. We'll just do them one at a time. We have y equals, parentheses, x minus 3 squared plus 5. And then let me just get another entry for y equals 5. That's going to be a horizontal line. There it is. And we see there's one spot where they are crossing. So at this spot where they intersect, 3, 5, that will be the solution to this system of equations. For this problem, they want us to solve this quadratic equation by graphing. So we're going to individually graph each side of the equation and just see where things cross. Let's go to Desmos. All right, so let's put in side 1. That's this x minus 2 squared minus 3. And you could write, but you don't have to write the y equals in here. You can just write it the way it is, and Desmos just kind of knows. So there's a parabola that describes. Let me make a new entry now and do the right side here. So we have x plus 3 and negative x plus 9 minus 38. And then we've got these two little spots down here where we're intersecting. So 2 comma negative 3, 3 comma negative 2. Because our graphs cross at those two spots, that means the solutions to this equation are going to be the x values 2 and 3. So x equals 2, comma 3, both x values. For this problem, they want us to solve this using substitution or elimination. Since we haven't really gone over elimination in the lesson yet, substitution seems like a good approach. It's a good approach anyway. We notice that we have a variable by itself, this y, so substitution is actually going to be the fastest way to do this one anyway. So what this means is we are going to replace one of these y's with whatever the other y equals. So we could write, for example, x squared minus x plus 2. If I substitute all of this for the first y here, all of that equals x plus 5. I also could have written x plus 5 equals all this x squared stuff, but I like having a positive x squared on the left side of the equation. It just feels right to me. So let's zero this out and try to factor it. We still have an x squared on the left. Negative x minus another x gives us negative 2x. And then 2 minus 5 gives us negative 3. All of that equaling 0. So two things that multiply to negative 3 and add up to negative 2. That would be positive 1 and negative 3. So x plus 1, x minus 3 equals 0. And now we'll solve for x and plug those back in to get some y values. We'll just do 1 point at a time though. So this first x plus 1 factor, that's giving us x equals negative 1. Plugging that back into one of these equations, I'm thinking this x plus 5 one is a little easier. So we have y equals negative 1 plus 5. And that means we have y equals 4. So negative 1 comma 4, first answer for that one. Now for this other one, we have 3 minus 3 equaling 0, so that's our other x value. Plugging that into x plus 5, we have 3 plus 5, and that's going to come out to 8. So that leaves us with 3 comma 8. For this problem, we're trying to solve this algebraically. Since I have one of the variables all by itself, this y right here, I'm thinking substitution is a good approach on this one. So I'm just going to take this stuff that y equals 2x minus 10 and replace the y in the first equation with all of that. So we've got 2x minus 10 quantity squared instead of y squared now. I'm going to go ahead and expand this so that I can start simplifying and solving this thing. So we've got the x squared that was there before. Now we have to square the first thing, so that's going to be 4x squared. And then we multiply these together and double it to get that 2ab term. So that's going to be, let's see here, negative 20x doubled is negative 40x. And then finally squaring the last thing, negative 10 squared is 100. And we still have that 20 on the other side. All right, let me get everything on one side and let's see what we have at that point. So x squared and 4x squared, we can add that up to get 5x squared. Negative 40x is still there, and then 100 minus the 20 gives us a positive 80. Now I notice these are all divisible by 5, so that would be a good next step here. That'll give me x squared minus 8x plus 80 divided by 5 is 16 equals 0. And this looks like one of those perfect square trinomials. We have two perfect squares with something between it. So I bet I can use my a squared minus b squared, or my a minus b squared shortcut here if I square root both of these. So we have the square root of x squared is x, square root of 16 is 4. Middle sign is negative, so I can write this as x minus 4 quantity squared. And just to double check, if I multiply these together and double it, I get the negative 8x here, so that works out. So then setting this equal to 0 and solving, we have just x equals 4. Now let me plug that back in to get the y value, and I'm thinking this y equals 2x minus 10 is way easier to use. So let me do y equals 2 times 4 minus 10. That's 8 minus 10, or negative 2. So we get the final answer of 4 comma negative 2. For this problem, deciding between substitution or elimination is a little bit trickier. We have y completely isolated in two equations, so this actually would be a pretty good one for substitution, but I'm going to show you elimination because it's almost as fast. So if I add these together the way they are, nothing's going to cancel, but if I multiply one of these by negative 1, then I could be in business. So let me label each of these, E1 and E2. And I'm going to multiply the first equation by negative 1 and then add that to the second equation. So this will be a negative y equals positive x squared plus 6x plus 10. And the second equation I'll just rewrite as is. So adding those together, those y's cancel. That leaves me with 0 actually on the left side. And then we have 4x squared plus 6 and 18 gives me 24x, plus 10 and 22 gives me 32. Before I go quadratic formula, let me see if I can divide this by a common factor. It looks like these are all divisible by 4. So dividing everything by 4, I'm going to have 0 equals x squared plus 6x plus 8. And then that looks very factorable, just two things that multiply to 8 and add up to 6. That would be 2 and 4. So x plus 2 and x plus 4. So setting each of these equal to 0 and solving, for my first parentheses I've got negative 2 zeros that out. And let me just plug that back in to get a y value before I forget to do that. Now between the two equations, these both look kind of equally nasty. So I'm just going to plug this into the first equation. So we have negative 2 squared minus 6 times negative 2 minus 10. This is negative 4 plus 12 is going to give me 8 minus 10 is going to give me negative 2. So negative 2 comma negative 2 is our answer for that one. That's kind of cute. Now the other branch here, if I set x plus 4 equal to 0 and solve that, we're going to have x equals negative 4. Plugging that into this negative x squared equation, let's see what comes out of that. So this is going to be negative 16 plus 24. That's going to be positive 8. 8 minus 10 is going to give me negative 2 again. Well, that's interesting. So we have negative 4 comma negative 2 as well. So those are our two solutions. For this problem, I'm thinking substitution or elimination would probably take about the same amount of time. Since I noticed that I have a positive and a negative y, if I just add these together, those are going to cancel. I'm just going to go with elimination on this, but either one would work. So let me label these E1 and E2, and I'm just going to add them together as they are, no changes needed. So that cancels out the y's here as planned. That leaves me with 0 on one side. And then on the other side, we have x squared plus 2x squared, giving me 3x squared. And then negative and positive 1, that also cancels out. So now, getting x squared by itself, if we divide by 3, that'll give us x squared equals 0. And then if I square root both sides, I get x equals 0. I could write plus or minus 0, but that's kind of silly because those are the same thing, or plus or minus the square root of 0. So this is our only x value. Plugging that back in, the first equation looks a little easier to deal with. So 0 squared minus 1 gives me negative 1 for the y value. So then 0 comma negative 1 is that answer.